So every year, SSERVI is proud to host a community awards ceremony, something that we started 14 years ago in 2009. These awards honor individuals in 4 categories and are open to members of the community throughout the world. And so for the first time, we're presenting one of these awards at ELS to an esteemed member of our Lunar community, who we all know. And I think this indicates that lunar science has no borders. We're all in this great adventure together. The award presented today is the Wargo Award and is named after Michael J. Wargo, who served as the chief scientist for the Human Exploration Enterprise at NASA and was a co-founder of our institute. We owe him a lot. He passed away suddenly in 2013, and the IAU posthumously named a crater on the lunar far side in his honor. This year, the Wargo Award goes to Dr. Ian Crawford. Dr. Crawford is someone known widely in our community for a whole lot of reasons. He made me promise to give a brief introduction, but I could probably go on for quite a while. For decades now, he's been instrumental in raising the profile of lunar science and human exploration in the UK, which, as a lot of us know, is not an easy task at all, but he's done remarkably at it. He has dozens of publications within the space policy literature, particularly those linking science and exploration with the human future in space. And just as importantly, he has supervised 12 doctoral students in these endeavors, assuring the future of his important contributions. So please welcome Dr. Crawford.
I will try and use this because the green light. Okay, great. Thank you, Greg. It's a great honor to be here. I have a slight case of imposter syndrome, but it's great. I'm very greatly honored, of course, by this award. And I never knew Mike Wargo personally, but he was a very enthusiastic and ubiquitous presence in the lunar exploration field, just as I was entering it 20 years ago. And I think his influence has been profound, and he left us far too early. And so it's great that SSERVI have established this award in his honor, and I'm of course greatly honored to receive it. So I've never done one of these acceptance speeches before, but Greg gave me instructions, and the instructions, I just put my glasses on, so I could. The instructions were to try and make it personal and not give a science talk. So I'm going to make it slightly personal, and I'm not going to give a science talk. But I do think science and exploration they're more than 2 sides of the same coin. They're really fully integrated. And I do have some slightly political point I'm going to make. But anyway, let me give you my life history. So as many of my colleagues know, I started life as an observational astronomer, and I came to planetary science relatively late, but it was frighteningly already 20 years ago. So when I was an observational astronomer, I studied the interstellar medium through high-resolution optical spectroscopy using ground-based telescopes. Those are the interstellar clouds in which I've just suggested alien debris might be accumulating. But that's anyway. The picture top right here shows the 74-inch telescope, 1.9 meter telescope at Mount Stromlo Observatory outside Canberra, and that's the telescope. I had 130 nights on that telescope, and that's a telescope that gave me the data for my PhD. And then sadly in 2003, the very year that I moved from interstellar medium to planetary science, the telescope, along with the rest of the observatory, was destroyed in a bushfire. So make of that what you will. But anyway, that's not why I transitioned from. I'd already made the decision, obviously, but obviously my bridge years were burnt behind me, literally, in there was no going back because the telescope had been burnt down. But anyway, that's not the reason I moved to planetary science. The reason I moved to lunar science in particular is, as will become apparent in a minute, is that I think the moon is going to play an absolutely fundamental role in the continued human exploration of the universe. But you don't make a career change like that without a lot of help. A lot of help from a lot of colleagues and teachers and far too many people to acknowledge here. So I've just listed the most important people, and the most important people, my PhD students and my postdocs, because without these, several of them are here. So I mean, I owe these people a huge debt of gratitude, because I really wouldn't be here in planetary science without these collaborations. A picture at bottom right, you may recognize three of us. This is at the Lunar Receiving Laboratory in Houston, where we were in 2009 collecting some Apollo 12 soil samples for a project that we were doing. But you on the left here, you see Joshua Snape, who's now doing a postdoc in Manchester, and on the right, Katie Joy, who's now a professor at Manchester. So I would say I am very, very proud of for a large fraction of these former students who've not only stayed in science, but are now occupying important and influential positions in the lunar and planetary science community. So I was asked to say, but beyond that, there are three. Everyone has some sources of inspiration. And I would say, if I look back at my life, there are three main influences that got me into astronomy in the first instance, and then into planetary science. So I was 7 in July 1969. So at that age, growing up with the Apollo program, don't let anybody tell you that the Apollo program didn't inspire a lot of young people to be interested in science, because it did. The very first time I stood up in front of an audience and gave a talk, I remember it well. I was in my primary school. I was 9 or 10. Apollo is 1971. Apollo 14 had just happened. Teacher knew of my interest in space and asked me to give a talk. And this shows several things. It shows that if you've got exciting things happening, then good teachers and good parents, I'll come to my parents in a minute, can leverage this for educational benefit. And anyway, but obviously the fact that I was obviously deeply inspired by the Apollo program. So everyone owes everything to our parents, of course, by definition. But here I just like to highlight especially the influence my father had on my life, I think. I mean, my father was a dentist, but he had an interest in astronomy, which sort of kept my interest going. But he was the person who woke me up in the middle of the night to watch Apollo 11, against the objections of my mother, of course, because it was far too late to get the young lad out of bed. But anyway, so he did that. And so that was an important influence on me. And then at the bottom, we see the Starship Enterprise. Now, of course, the original Star Trek series also dates from this era, and is also very inspiring. But I want to make I'm going to, maybe if I have time at the end, come to a slightly more political point. Beyond the excitement of exploring the universe in the Star Trek universe, there is a geopolitical societal backdrop. And this was one of Gene Roddenberry's big part of his vision, was that we were going to explore the universe together. I mean, not only as a united Earth, but as a united federation of intelligence in species, including non-human intelligences. This was a fantastic vision. And I think it's something we should be aspiring to try and develop. Only people of a certain age and possibly a certain nationality will. Does anyone recognize this moon base? Okay, so some people. So this is Moon Base Alpha. From the 1970s, so I should have said the third thing that influenced me was not just Star Trek specifically, but science fiction in general. Anyway, one of the science fiction shows that was being broadcast in the 1970s was Space 1999. And that seemed a long way in the 20 years in the future from the 70s, right? So from the vision was that this is what by the turn of the century, we would have a moon base, and it would be like this. And we're still waiting for this moon base. But our responsibility is to make it happen. It didn't happen by 1999. It hasn't happened by 2023. But there are very good scientific reasons for wanting to build a moon base. So we should keep advocating for it. Now, to say something about exploration. So the space agencies had a mantra, which I think fortunately has slightly gone away now. And the mantra was, science enables exploration and exploration enables science. Well, that's fine as far as it goes, but the truth is that it still is predicated on a dichotomy. They're two different things and one supports the other. I think this is the wrong way of looking at it. I think exploration is a part of science. And I think science, I take science to mean the systematic exploration of the natural world. Then within the natural world that we are exploring the solar system and the universe in general is clearly a part of science. And then developing the tools, the spacecraft, the astronauts that go out and explore the universe, then this is what we call exploration, but it's a subset of science. And so it's not helpful, forgive me for the agency people here, I don't think it's helpful for the space agencies to institutionalize a separation, to have directorates of science and directorates of exploration. I personally think this is unhelpful because it institutionalizes a division that doesn't really exist, and that we should be viewing exploration as a subset of science, broadly considered. The English, Alan Chapman is an English historian of science, and he's made the point, thinking back to the voyages of exploration, the European voyages of exploration in the 16th, 17th centuries, that the ships that were going around the world, I mean, the reason the botanical gardens at Padua, just down the road, were established, so like the ones in Leiden and other university towns around Europe, was because these totally new species were being found by these voyages of exploration. And so the universities needed, amongst other things, botanical gardens to study this fantastically new flora that was being discovered. Now, Chapman's view was, of course, we wouldn't have these exotic plants from far away without the ships, the sailing ships that explored the world and brought them back. So his view was that really these ships that went around the world during the voyages of exploration, and therefore by definition their crews and the training of the crews and everything, these essentially are just extended scientific instruments, like the telescopes and the microscopes that were being developed at the same time. So I think we should be viewing exploration as an integral part of science. I have a quote here that I think gives the best definition of exploration, though. This came from someone called Craig McLean, who was from the US National Oceanographic and Atmospheric Administration, and he was here talking about oceanic exploration. But this quote applies to all exploration in general, I think, including space exploration. And so we've got, without exploration, we would continue on our familiar path with familiar subjects, enjoying an occasional surprise. But with exploration, it's our purpose to discover these surprises. I mean, you would not have discovered new plants and new animals on the other side of the world by just carrying on normal science in the 17th century. You had to build the ships to get out there and explore, and then you find these things. Just a couple more slides left. I'm not sure how much time I've got anyway, obviously we are lunar scientists here, and it is possible to get focused, and we should be obviously our speciality is the moon. So there's a tendency for us to get perhaps overly focused on the moon, and we should, because the moon has a lot to tell us about the history of the Earth-Moon system, the universe. But I think the reason that I moved to lunar science when I did was because I knew that if we're interested in exploring the universe, we've got to start somewhere. And there is only one place to start. The place to start is the moon, because the moon is the closest planetary body to us, where we can develop, while we explore the moon itself, which is a very important astronomical planetary geological object to explore in its own right, we're also developing the capability that will take us further afield. So there's a quote from the German-American rocket engineer. Some of you may be familiar with this quote, Kraft Enrique, who was a long advocate of solar system exploration. And he said that if God had wanted man to become a spacefaring species, he would have given us a moon. And so here we are, we have a moon, so we should be making use of it. And of course, it will help us develop the capability to get to Mars, but it would equally be a mistake, I think, to view Mars exploration as an end in itself. The exploration doesn't have to end Mars, but we will need to develop a lot of stuff on the moon to get to Mars. The exploration doesn't have to end and before we get to, or after we get to Alpha Centauri, which is, oh, I don't know whether does he? Oh, here we go. Yes, you recognize the southern Milky Way here. This is the Southern Cross, Alpha and Beta Centauri. So there's our nearest star. We know that Proxima Centauri, which is one star in the Alpha Cen system, has a planet. It's only 4 light years away. Of course, 4 light. Oh yeah, okay. So 4 light years is a small distance in astronomical terms, but if you want to travel four light years in a time scale that's at all commensurate with human civilization, then that forces you to build something that can travel at like 10% of the speed of light. That's an enormous technical undertaking. We can't do it yet, but I think we kind of know that if we did want to do it, it's such an enormous undertaking that it's going to probably be much easier for a civilization that has significant industrial capability developed in the solar system to eventually take on that challenge. And if we want to build an industrial technical capability in the solar system, then the moon is the place to start doing that. I believe, yeah, this is my last slide. So Jayton had already shared this beautiful picture. Obviously, it shows the Earth and Moon from Artemis 1. But I think we look at this picture, and maybe this is something that I got from from Gene Roddenberry via Star Trek, I think. You look at this picture and it carries the perspective. So I may sound very naive at this point, but I guess the joy of being able, the privilege of being able to do these acceptance speeches is to say what you think. I think almost fell down the stairs. That I think the perspective that you look at this, and what do we see? Well, we see the Earth, and the Earth is already looking small. From this perspective, it even looks smaller than the Earth. And so the whole, not only the whole of human history, the whole of evolutionary history, the whole of 4 billion years that's led to us, plus the whole of human history, it's all been played out on this relatively small planet, and we're about to go and explore the wider universe. So there is something wrong. There is a disconnect between thinking we should be going out into the wider universe and exploring it as kind of separate, nationalistic, tribalistic identities. It just doesn't make, I know this is what we're doing. I'm aware, of course, I'm not totally naive. I'm aware of the history. I know why the Earth is split into these different national tribalistic units. We could all, but there's still something doesn't mesh. The political and other tribalistic divisions on this small planet are not really commensurate with the scale of the activity that we're about to embark on. And this is where I think Roddenberry's vision of trying to unite humanity in the exploration of the universe was very much on the right lines. And I think it's what we should, so scientists are often not very comfortable making political points, and this is a political point. But I think it's a political point that needs to be made. I'll finish there. Thank you.